This is a new playlist, and that will contain the problems of electricity and magnetism. That means the previous playlist is not over yet. There are many more problems needs to be solved, and I'm going to solve them simultaneously. But this is perhaps the requirement of time when I need to introduce these things. And this is the first problem at your screen. They are not going to ask it. Yes, this problem is important from the point of view of Olympiad, but I'm not going to discuss Olympiad right now. I will take in the second phase. But why this problem? Why I'm going to solve it? Why I'm stressing on this problem? Because one of the reasons is this is the most misinterpreted problem in the history of plus two coaching in India. And I'm not blaming anybody. I'm not criticizing anyone, any particular person, or any particular group of person. But this is just for the sake of clarity that somebody is going to ask this problem from me. They will write in comments or like this. But so I wanted to give an explanation to them. So I'm giving some kind of explanation. I'm not actually going to solve it because this is not the right time to solve it. But the right time will also come, and I'm going to solve it. But especially in a different playlist, basically for Olympiads. And the statement of the problem is two semi-infinite homogeneous dielectrics with dielectric constants K1 and K2 are in contact along an infinite plane. And two charges Q1 and Q2 are placed at equal distance A from this plane along the straight line perpendicular to it. Find the forces F1 and F2 acting on the charges. And why are these two forces not equal? Are we violating something called Newton's third law of motion? Of course not. This is some kind of infinite plane, and there is a boundary of them, and there are two divided into two semi-infinite this one left and right, two semi-infinite planes, and this forms a complete infinite plane. And there are two homogeneous dielectrics with dielectric constant K1 and K2, and there are two charges placed, say Q1 and Q2, in these two semi-infinite planes, and their distance is A from the boundary. That means the distance between the two charges is 2A. So what are the forces acting F1 and F2 on charges Q1 and Q2? I'm going to answer it. The net force acting on charge Q1, I'm not going to solve it. In fact, I'm going to write down simply the answer, because this is not the part of plus 2 syllabus. You need many things to learn, some mathematics and some physics to solve this problem. And I know that this is not the part of syllabus of plus 2 in our country. So they are not going to ask in IITs or other things. But this is the part of syllabus of Olympiads where they can ask this problem. And so I'm simply going to write the answers because I have solved it many times. So answer the force on charge Q1, that is F1, can be simply given as K1 minus K2 divided by K1 plus K2, Q1 square by 4A square plus Q1 Q2 divided by 2 K1 plus K2 A square. And the charge on the force on charge Q2, that is F2 in this case, can be simply written as K2 minus K1 divided by K1 plus K2 Q2 square by 4A square plus Q1 Q2 by twice K1 plus K2 A square. And this expression for the forces may be obtained in various ways. First thing you need to consider, the first method, when you might be considering the interaction between 2-point charges simply. And the second method of calculation of this force is that you need to take into consideration that the point charge, which is due to bound charges on the separation boundary, which is this, you need to consider the bound charges on the separation boundary as well. And all the two consideration, the force of interaction between 2-point charges and the force on the bound charges on the separation boundary, with the aid of Maxwell stress tensor. This method is applied. Method name is Maxwell stress tensor. And you don't know any of these methods. If people know simply how to consider the interaction between 2-point charges, but they don't know how to take the bound charges on the separation boundary and how to use the Maxwell stress tensor. So they provide many sort of answers that is all incorrect. But this is the problem. This is a problem. This is, some people declare it, this is a non-problem, you don't need to know about this. Yes, you know to need about this. This is a real problem. This is not a non-problem. You just don't know how to solve them. The methods you need to learn to imply to solve these kind of problems. This is simply not taught in +2 because this is not a part of +2 syllabus. But that means this is not, the problem is not correct. And I would like to answer the second question, why are two forces not equal? Because the fact that the forces acting on Q1 and Q2 are not equal is due to the fact that the two charges do not by themselves form a closed mechanical system. There are also some other charges. There are also bound charges on the separation boundary between the two dielectrics, and vector sum of forces on the boundary and on the charges Q1 and Q2 both are equal to 0. And I guess you are not getting this. So because there are many more theories, that means more theoretical and more mathematical practice you need to solve this problem. I'm trying to answer to those who perhaps solved this problem earlier in their lives. Otherwise, this problem doesn't mean to you anything. And well, I want to tell you that yes, indeed, this is a problem, and you don't know how to solve them. So don't try to solve them when you are studying in +2. When you move up, you will learn to solve these problems. And I guess many of the people who are trying a trick to answer this question are also not taught in proper manner. So I'm sorry for them, but the answers are correct, and I will give the complete explanation, but in my Olympiad section, not in this IIT JEE section. So thank you for watching now.